Very nice example that can be solved using two-dimensional representation. A ball is dropped from a height of 39 meters. The wind is blowing horizontally and imparts a constant acceleration of 1.2 meters per second on the ball. Find the value r and theta. How long does it take for the ball to reach the ground? With what speed does the ball hit the ground? Let's look at how the motion looks like under these conditions. If there is no wind, the ball would be falling straight down following the H path. This would be the ordinary free fall motion with acceleration g. But of course, this is not the case here. Here, we have wind that imparts additional horizontal acceleration a, and because of that, ball will move along another path, as you can see from the visualization. Let us assume the following. At the end of the motion, or when the ball hit the ground, that will be at the position r and the angle theta. Therefore, we are going to solve two one-dimensional motions instead of one two-dimensional motion. First, we will concentrate to the perpendicular component of the motion. Afterwards, we will solve horizontal component of the motion. Okay, let's observe the perpendicular component. We have a motion with acceleration g without initial velocity. So, from the equation for h, we can calculate the time needed for the ball to touch the ground, which is 2.82 seconds. Now, let's observe the horizontal component. Here we have a motion with acceleration a. Therefore, we have the equation for r, and again without initial velocity. So, the r is 4.77 meters. Now, we will find the angle theta using right triangle with two legs h and r. From this triangle, tangent of theta is equal to h over r, but at the same time it is g over a. Nevertheless, theta is arctangent of g over a, and it is 83 degrees. Finally, as we have motions without initial velocity, the components of the velocity have these values. The horizontal component is a times t, and it is 3.38 meters per second. The vertical component is g times t, and it is 27.66 meters per second. And finally, the magnitude of the velocity at the moment when the ball hit the ground is 27.86 meters per second.